Classwork 24. Let's see question 1. A ball is thrown into the air from the roof of a 200 foot tall building with an initial upward velocity of 80 feet per second. So its height function is given by this. So it's a quadratic function. And the leading coefficient is negative 16. So we get a downward parabola. Downward parabola will have a maximum. Okay. So the question is asking, what is the maximum height reached by the ball? So looking for the function value at this point. So this point, so this is called the vertex. So looking for this point, this vertex value t and the edge of t. That's our goal. So how do we do that? Remember, the formula for finding vertex is a t, the variable here is t, is negative b over 2a. B is a number before the variable t, which is 80. And the a is a number before t squared. So negative 16 times 2. Or 2 times that, right? Negative times negative become positive. 2 goes into 80 40 times. So 80 divided by 2, 40. Then 40 divided by 8, 5. 16 divided by 8, 2. So I'll get 5 over 2. So t is 5 over 2. So t equals 5 over 2. So now we need to evaluate the height at 5 over 2. 5 over 2. So we just plug in 5 over 2 for t into the function h of t. So negative 16 times 5 divided by 2, then square, plus 80 times 5 over 2, then plus 200. So get negative 16 multiplied by 5 squared, 25, 2 squared, 4, plus 80 divided by 2, 40. 40 times 5, 200. Then plus this 200. So 4 goes into 16 4 times. Negative 4 times 25 is negative 100. Plus 400 plus 200 plus 200, that's 400. Negative 100 plus 400, that's 300. So the maximum height reached by the ball is 300 foot. Okay, so basically it's a quadratic function given. The maximum height possible is given by the vertex. Let's see question 2. We're on the graph absolute value function. So f of x equals the absolute value of x. We call this like a basic functions for absolute value function. And its graph is this one, we call reference graph. So basically, what does a reference graph do is, if we graph any other function involves absolute value, so we can go back to think about this graph. So take this graph as a reference graph. So one way we could work with the 3 points, right? Because we see this graph. So on the left-hand side is a straight line. On the right-hand side is a straight line. And we call this also vertex. Right? So this is vertex. So let's pick other 2 points. So let's pick this point to work with. Let's pick this point to work with. Because it's straight line, so 2 points defines a line, right? So this point, we have negative 1, comma 1. This point is 1, comma 1. And the vertex is just 0, comma 0, the origin. We could make a table value. So let's see, this is the x value. This is the absolute value of x. This is the absolute value of x plus 4. But we picked the x equals -1, x equals 0, and x equals 1. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of x plus 4, so -1 plus 4, that's +3. Absolute value of 3 is 3. 0 plus 4, that's 4. 1 plus 4, that's 5. Okay. We might need a couple more points for this one. Okay, now let's graph this one. So we have -1, +3. -1, +3. So we have this point. We have 0, 0. We have no 0, 0. We have 0, 4. 0, 4. We have this point. Then we have 1, 5. 1, 5. And these 3 points are collinear. Collinear means they're on the same line. So this just gives us one side. So not good enough. So what do? We want to evaluate more values. Let's pick more points. So let's pick -5. Absolute value of -5 is +5. So we get this point. So we get this point, right? -5 becomes 5. But then -5 plus 4, that's -1. Absolute value of -1 is 1. Then maybe we do -4. Absolute value of -4 is 4. Right? Absolute value of -4 is 4. So this point. Then -4 plus 4 is 0. Absolute value of 0 is 0. So let's graph those 2 points. So -5, 1. -5, 1. And -4, 0. -4, 0. Okay, now we have 2 sides. Oops. Straight line. Okay, just think this is a straight line. And the other side also straight line. So the V shape is here. Now let's compare these 2 graphs. Let's compare this one with a reference graph. Do you see every point being moved to the left 4 points? 0, 0 now moved to be -4, 0. And -1, 1 moved to be -5, 0. -5, 1. Right? 1, 1 now moved to be -3, 1. So all the x values being subtracted 4. So that tells us, so this, let's call this G. This don't call F. This is a horizontal translation of F. It's F of x plus 4. Okay. You can always go back to table value method, all right? Otherwise, you can just graph by translation. And translation is one of the transformations. So we have 3 kinds of transformations. One is translation. Translation could be horizontal translation, push to the right, push to the left, or vertical translation, push up or push down. So this is horizontal translation or horizontal shift. So the graph, every point of the graph being shifted 4 units to the left. Let's see, 3. So 3, we're treating x squared as reference graph. Let's call this a G. G of x. G of x we can write as a 2f of x minus 1 plus 3. So basically, this is saying g of x is the transformation of f, right? So we have this horizontal shift. Because it's a minus, x minus, so this is right, shift to the right. Before with the previous question, we have x plus 4, then shift to the left. Then we have this stretching. Stretching is like a dilation, stretching or shrinking. If it's bigger than 1, it's a stretching. Less than 1, like a half, it's a shrinking. Then we have a vertical shift. So vertical shift up, plus 3. All right, let's do step by step. So we started with x squared. So this is a graph of x squared. We also work with a couple points. Let's work with 3 points. So we need to remember the shape of the reference graph. So we also work with 0, 0, 1, 1, and negative 1, 1. You can pick other points to work with, okay? Now let's graph x minus 1 squared. X minus 1 squared. So here it's just x squared. Now x minus 1, the points being, you can use the table value as well, right? But I want to use transformation. So x minus 1 means all the points being pushed to the right 1 unit. So 0, 0 now becomes 1, 0. Push to the right means add to the x value. So 0 plus 1 is 1. Then 1, 1 becomes 2, 1 now. Negative 1, 1 becomes 0, 1 now. So then I graph like a parabola. Okay, roundish. So this is the x minus 1 squared graph. Then this have a 2, stretching. I multiply 2 with the function value. So I also work with the 3 points. 1, 0, 0 times 2 is still 0. So I still have 1, 0 point. Then 2, 1. Now 1 is being multiplied by 2. So this is a 2 times x minus 1 squared graph. So I have 2, 2. Before was 2, 1. Now it's a 2, 2. Then before was 0, 1, but 1 times 2, I have 0, 2 point. So these 3 points. Also, I graph like a roundish, not straight line, like a roundish. Oops. Okay, so this is a graph of 2 times x minus 1 squared. So last one, I graph 2 x minus 1 squared plus 3. So every point is being pushed up 3 units, means the 3 points, y value add 3 to the y value. So 1, 0 now, 0 plus 3 becomes 1, 3. So the vertex becomes this point, 1, 3. 2, 2, the second 2 plus 3 becomes 2, 5. 2, 5 becomes this point. Then 0, 2, 2 plus 3 becomes 0, 5. And the shape still the same, still roundish, parabola. This is the final graph. If you have trouble with this, you can always go back to the table value. You assign x some values, then you evaluate x minus 1 squared, then you evaluate 2 times x minus 1 squared, then you evaluate this one. Okay, you can graph that way. That will take a little bit longer time. Let's see 4. So 4, we have a piecewise function. The first piece is constant function, right? If x is in the interval from negative infinity up to 1, it acts as a constant too. If x is from 1 up to past to infinity, not including 1, it acts as 3x. Let's evaluate those. So f of 0, 0 in the first interval, right? So that means equal to 2. F of 1, 1 is also in the first interval, it's 2. F of 2 in the second interval, so 3 times 2 is 6. 1.5 is in the second interval, so I have 3 times 1.5, which is 4.5. Now let's graph. Let's graph. Let me move this. So we have to remember the function. Let me write the function on the side. So f of x equals to 2 when x goes from negative infinity up to 1, right? F function equals 3x if the interval is from 1 up to infinity. So let's graph the first one. First one is, let's look for the number 1. 1 is here. And the function value is 2. And 1 is in the domain. So we draw a solid dot. Then we draw a line, heading towards the negative infinity. Okay. So this piece would be f of x equals to 2. In the interval from negative infinity up to 1. So the second piece, we need 2 points, right? So 1 is not in the domain, but however, we want to evaluate 1. So 3 times 1 is 3. So 1, 3. But we make an open circle because 1 is not in the domain of the second interval. 1 is not in the second interval, so we make an open circle. Then we use 2. X equals 2, we get 6. So get this point, right? 3x is a linear function, so we know get a straight line. So 2 pieces, and that's it. So the left piece, right, from 1 down to negative infinity, here we see a solid dot because 1 is in the interval. 3x, the interval is from 1, but not including 1, so we'll make an open circle. Okay, that's it. That's the classwork.